Go live, go live. Am I live? Is it live? Oh my god, it's live! Is it live? Oh my god, it's live! Oh my god, echo! Oh my god, it's live! Oh my god, echo! Oh my god, it's live! Alright. Oh my god, echo! Oh my god, it's live! Alright. Oh my god, echo! Oh my god, it's live! Alright. Oh my god, oh my god. Echo! Echo! Can echo? Can echo? Can echo? Can echo? Can echo? What the? How loud do I have to speak here? Let me turn up the audio. Gain. Where is the gain? Gain. Yes, 15 decibels or something. 15. 1 5. Hello. God, I need to go check. Is the stream doing well? Oh my god, it's live. Oh my god. Shut the hell up, me. Oh my god, it's live. Oh my god. Shut the hell up, me. It should be doing well now. It should be doing well now. Okay, so let me restart the timer. It's not supposed to be a long stream. It's supposed to be a short stream where I do whatever the hell I want. Do I have... Yeah, let's restart this. Okay, the timer is restarted. Hello, Olive Swag. Hello, Carol Ferris Young from my secondary school. Hello, me alone who's doing this. Okay, so I need a YouTuber voice. My voice is too monotone right now. Yo, what's up, guys? Today we're going to learn about... First of all, I need to check this real quick, the stream once more. The latency is crazy. The latency is super crazy. Okay, so it's not going to be a long stream. I said this a billion times. You don't need me to say it again. God. So this is what I found out, right, recently. Basically, in studies, right? In studies in the Google Drive I share with you guys. Turns out, our current batch's chemistry notes, like lecture notes, like for chemistry exactly, it's the exact same as our past chemistry, our seniors chemistry slides. So we could just study everything in their general chemistry and it'll still apply for them. I mean, no, for us. That's one of the great things, right? So the only bad thing about this, right, is the fact that I don't know the naming scheme of our seniors lecture notes. Like, what does it mean by 1A, 1B, 1C? That's stupid. It's stupid. It's completely stupid. But it's necessary for us to read through. Wow, I should not have started this so late. This is such a... Oh my god, the stream is very latency. I'll just use my 2025, 2026. chemistry thing. So week two we're going to have lecture 4 to lecture 6. Alright. For some reason lecture 4 is a bit different because it's in PowerPoint form, which is incredibly strange, and one of the worst things about PowerPoint form is that I can't access the PowerPoint form on my Google Drive natively, which is terrible. So I have to go to MC365 Copilot to access it, which is stupid. And it keeps crashing. Great. Alright. And I forgot to download it. Great as well. And the worst thing about University of Malaya, the course in general, is that the internet is terrible. But to be fair, it has like hundreds of students. Let me open it. Let me open. Oh, love to open. Okay, lecture 4 chemistry. You wanna get WPS Office? Not really. Wow, are you gonna promote WPS Office? Maybe I'll try it out. Always stay hydrated. Staying hydrated is great. So what are the topics in for the fourth one? I can tell that it's from the same. It just works really. I'll try it out next time. Wow, my battery is low. Let me go. Nah, I don't need charging. So the topics is about relative atomic mass force, blah 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 blah. Some things that we already know. Where's my pen and paper? I need my pen and paper for this. Wow, where did my notebook, my lovely notebook, and a pen. Yo, what's up, guys? What's up to the new people who joined? Just text. If you're part of PASUM, right? If you have any questions that's not bio and social science, you can ask me, and I'll try to answer it the best I can. So the topic is about. Right now, the topic is about. Let's see. So there's a lot of topics, right, in chemistry. Lecture 4 chemistry notes. The mass spectrometer, mass empirical formula. I should probably switch to a thicker pen because you can't see this on stream. Either that, I'm just blind. Where's my pen? Gotta look for my pen. There's my big, good pen. So for lecture 4, there's stoichiometry and atoms and molecules. Stoichio. Alright, concentration, homogeneous mixture. Okay, this expands more on the homogeneous mixture. I don't think that's... Concentration is the ratio of the amount of solute to the amount of solvent. Is there a formula for this? What's this? Amount of solute. So it's amount of solute to solvent. Solvent. Alright, let's see units of concentration. Oh, is this the part where it teaches about molarity and molality? Wait, I think this might actually be the molarity and molality part. Okay, so it's moles of solute and V. Does it not count? Okay, solvent is volume of solution. Okay, that's already one of the things that I'm confused about. I got confused very quickly. Volume of solution, but the top slide says something about... I don't think you can see this. Can I zoom in? Is it possible for me to zoom in? Oh, I can actually zoom in. We gotta see if this actually zooms in well enough. Yeah. So one of the things that I'm confused about is solvent and solution. Is it a different thing? Isn't a solution supposed to be a combination of two? Why in the next slide it just immediately talks about the volume of solution, N over V? That's... Oh no, this is concentration. It's a completely different topic. So I should not get this confused, okay? Concentration. Wait, is it molarity? Or is it part of molarity? I think it might be just a subset of molarity. So I'm just going to assume that it is for now. If it's wrong, then most common unit of concentration. So what's the other unit of concentration? Is there any other units of concentration? This example exercise. Preparing stock solutions. How to make a stock solution. I think, okay, this is what I think, right? Lecture 4 feels like something that would be a killer lecture note for the others. Because this is where it starts getting out from the basics. Actually, no. Is this still considered basic? I'm just gonna say no. It's a derivative of the basics, so it might be a bit difficult. So dilution, stock, okay, blah 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 blah. There's so many examples in here. Oh, this is where molality comes into play. I think I'm gonna write down all the units first, cause I can't remember everything. So units of concentration. Okay. Concentration. This is a game of concentration. Molarity. Satu. The molarity. So the first one is molarity. Hello, Bobola Daging Enak. You're my number 2 fan for some reason. Hello, my number 2 fan. Molarity, which is mole over. Wait, is liter measured in dm? Wait, what? I did not know this. Let me go. Okay, let me go look it up. Let me hold on. Oh yeah, it's just spectrum. All right. Where's my other keyboard? Did I leave my other? Okay. Okay, there's this my other keyboard. I know, crazy. I have 2 keyboards. Type. Okay. What is liter in I don't know, dm? Convert cubic dm. Okay, let's see. Check my math. I'm gonna check my math real quick. I feel like I'm missing something. Okay, let's see. 1 dm is, how much is that? Oh, okay, I did not know that. Okay, you learn something new every day. So 1 dm cube is apparently 1 liter. That's very interesting. Okay, that is very interesting. That's one of the first things we learned just now. So it should be obvious that it should be molarity equals mole over liter equals mole over dm cube. Okay, that's very interesting. Now the second concentration thing, stock solution. I don't think it's a concentration thing. Molality. All right. The second variation of this is molality. Molality is it's based on weight over kg. Mass of solvent, mass of moles of solute. Where the fanboys at? Sorry, there's no fanboys here. Unfortunately, that was just a thumbnail I used to bait you into joining into the watch along. Delicious water. Stay hydrated. So what's the point? Okay, molality is the number of moles of solute dissolved in a 1 kilogram of solvent. Unfortunately, you got scammed. I'm a scammer. I'm a big scammer. Stay here if you want to see fanboys in the future. Don't stay here if you don't want to see fanboys in the future. You're forced to stay. Make sure to like this video. Alright. So let's continue on. Units of concentration. There's other units of concentration. There's number 3, percentage concentration. Alright. Number 3 should be percentage concentration. Did you bring the wig to PASUM? Unfortunately, I did not bring the wig to PASUM. I might buy a new one somewhere in the future though, because I am planning on cosplay in the future. But problem is, now is not the right time. I'll think about when I'll get one though. Maybe somewhere on the 5th week, maybe. around next month. I'll have to think about it. Also, the wig is very fried right now. It's not exactly a good looking wig right now. It's kind of fried. It's, if you don't know what fried means, it does not look very good. It looks like you dipped it into boiling hot oil. Jesus. I mean, sorry. Jesus is very religious. Oh, golly. There's, what the hell is this? Parts per million, parts per billion. ppm. Mass and units. This is for molality. Parts per trillion, mole fraction. Okay, this is relatively self-explanatory. Mole fraction is pretty self-explanatory. It's just two different the moles of solute and solvent over each other. Actually, no, all the components. Use weak priest island. Okay, yes. That was one of the things. Okay, Zach, that was one of the things I was thinking about as well. Because I'm planning on live streaming anyways. All right. I was thinking like it might actually be helpful if I were to cosplay here. So yes, that is a very good idea, and it's something that I'm planning to do in the future as well. Thank you. Oh, that's not exactly that much apparently. Concentration. I think that's just another way of doing concentration. So mole fraction is another way. Mole fraction. So this entire chapter is about mole fraction. Yeah. Dilution. Stock solution. I don't think. First of all, I don't think it's dilution here, right? Dilution is actually that related in a way for this. For now, it might be related to a lecture in the future, but just not a lecture now. So let's start from the beginning again. We already went for the first pass. Always stay hydrated, by the way. So concentration is the rate amount of solute to the amount of solvent. From what I know, alright? So a solution is a combination of a solute and a solvent. How I will confirm this is by asking ChatGPT. Okay, ask what screen? What's the difference between a solvent and a solution? Is a solution a combination of a solute and a solvent? Now we gotta wait for a bit. The reason I'm drinking so much water is because
solution, a homogeneous mixture containing a solute and a solvent.
Alright, that's where we got it. Which it literally says right here. And I did not read it. Solution is a homogeneous mixture. Oh yeah, if any of you don't know what homogeneous means, homogeneous mixture, it means a solution that's like mixed well together, like Milo in water. So solution, amount of solute, units of concentration, volume of solution. And what the hell is this? Concentration, units of concentration. So why is there different? That's incredibly confusing. Since concentration is already defined as, what's it? The ratio of amount of solute to the amount of solvent. But the problem is, there's another unit called, you just registered today? Oh really? Registered today to PASUM? Are you a scholarship student by any chance? Molarity is the most common unit of dissolved in 1 dm. So okay, I know it's something that I'll have to accept, but it doesn't. Okay, let's see if why are you talking about femboys? Because of the thumbnail. The thumbnail is very much a femboy. Not a femboy, a cross-dresser. That's a very big difference between the two. I'm a cross-dresser. Stop, do not talk about femboys. I do not suggest you guys talking about femboys. Let's talk about chemistry, alright? We're PASUM students, alright? For except for social science people, you guys can talk about femboys. But for physical and higher students, we're talking about chemistry right now, right here and now. By the way, I don't know if you guys can actually hear me well. Okay, is the audio good? Is the audio doing well? Alright, while I'm waiting for your response, preparing solutions. How to make a stock solution? G. We are a solid solute. Okay. Basically, we are. Alright, that's good to know. I think I know who Pretty Pink is, considering how they write. So, solid solute. Okay, let's say, okay, using the example, this is the NaCl, right? You guys can't see. You guys, why is this so much to the left? Let me spin this around. Let's see, wait, I can literally just see my... This should be way better, right? It should be way better. So, given weigh out a solid. So let's say this is salt. Let's say this is salt. How did the pen just transform into this version of the pen? There's the pen. So this should be NaCl. We need to weigh out this first. Use a volumetric. Oh, volumetric flask. This is very precise. So solvent H2O. Use a volumetric flask. But what does G mean? G is gram? Wait. Mass times is that liter? What's L mean? Liter? Volume of solution, liter. So wait a minute. Gram equals molar mass. What's the unit for molar mass? Molar mass unit is mole per... Wait, what? Grams per mole times the mass of the solute, the mole. Okay, the mole times the... This, what? How do we get volume? Am I stupid? Does G actually mean gram? Oh wait. But GL L moles per L. Yo, this comes what? When in doubt, always ask your lovely Gemini. Okay, dear Gemini. Oh, great AI overlord. May you. Oh, okay, this keyboard is okay. Might you bless me with the knowledge of how gram equals this molar mass. I am forever grateful for any useful answers you may provide me. Alright, let's ask them about it and we'll see what they're asking. Rearrange of molarity formula. Wait, it's M. Wait, hold on. Wow, this is unreadable. Okay, so turns out M is not mass. At least I don't think so. Molar mass of solute. Mole. What the hell? What the hell? That's a little confusing. M is molar. That was what I was thinking as well, but like it is actually molarity. Okay, it is actually molarity. Yeah, it's actually molarity. So it's okay. That makes a bit more sense now. M times L is supposed to be the volume, right? Times molar mass. Okay, so let's try to figure out the units first. Mass. Okay, with the new information, mole. This should be mole over liter. Mole over liter. Was it? No, it's mole over. Oh my god, I'm getting things confused. Mole over, wait. What the hell, wait. Yeah, it is mole over meter. What the hell am I saying? Mole over liter times, this is liter, okay, and times gram per mole. Alright, so this cancel out this, that. Okay, you actually do get a gram. Is that you on the thumbnail? Yes, that is pretty much me on the thumbnail. That is quite literally me on the thumbnail. My ulcers are hurting. It's hurting me so badly. Okay, so I think with that knowledge, we should be stock solution, huh? So where is solid solute? Dissolve in quantity, use a volumetric. I don't think this. Make a stock solution from a concentration. Okay, what does a stock solution mean again? I don't remember. What's a stock solution? Concentrate.
A stock solution is a concentrated solution intended for dilution to a lower concentration for lab use.
Intended for dilution to a lower. Oh yeah, I get it. So basically a stock solution, right? So basically a stock solution is something like this. Let's say you have a 2 mole per hold on, I don't 2 mole, okay, just 2 mole. 2 mole of, let's say, hydrochloric acid. Let's say. And 2 mole of hydrochloric acid, considering the fact that it's already a strong acid, you have 2 moles of it. That is pretty dangerous. So we sealed it tight in the container. So let me draw a let me draw a little bottle over here. Since it's a container, right? Okay, this stock solution. This becomes a stock solution. Stock solution is incredibly concentrated. You do not want that anywhere close to your hand. So the reason they brought this up first, preparing solutions, right? It's because they want us to talk about something about dilution, okay? Like turning, let's say 2 moles of hydrochloric acid into a safer form, 0.1 mole of hydrochloric acid. I don't know if that's actually, I don't actually remember how this is actually written, but I think that's how it's written. So, stock solution from concentrated solution. Okay, let's see. M1, concentration of stock. M2, concentration of diluted solution. V1, need a stock. Okay. I think I get it. Somewhat. So M1 V1 equals M2 V2. So the concentration of stock and concentration of diluted solution. It should roughly be the. Is this lecture 4? Yeah, it is lecture 4. It's lecture 4. Very much lecture 4. Okay, concentration of stock and diluted solution. So from what I know, right? This. Okay, let's imagine the formula in visual form. So let's have a little box, right? Let's have a little box. You can't see this, so I'm gonna move my thing over here, and I need to wait for this to update so that I know that you guys can actually see this. And yeah, you guys can actually see this. So let's imagine this is 2 mole HCl worth of acid. So let these tiny balls. Okay, this is 1, 2, 3, 4, 5, 6, 7. Okay, let's just use 7 balls. 7 balls, alright. And what's next? Let's assume this box is around, I don't know, like 1 liter, because it makes things simple. 2 moles, 1 liter. And let's say we want 7 balls equals 7 balls. If you think about it, this is basically a geometry question. 1, 2, 3, 4, 5, 6, 7. 7 balls. 1, 2, 3, 4, 5, 6, 7. So we don't know how concentrated this is. Wait, molar M1 should mean a concentration. What's the concentration formula again? Concentration, this is a game of concentration. Mole per liter. So M should be mole per liter. Alright. So for mole per liter, how would it be like? Okay. Mole per liter. Since we're just in the end we're just trying to figure out the molarity of this. So let's say this is a water of, let's say 5 liter, just any random number with the same amount of molecules. We don't know how concentrated this is. I should probably put mole per liter or something. Wow, this is making me confused. I'm getting confused. Let me drink another sip of water. I know the concept, but I can't explain it right now. So let's retry. So M1V1 equals M2V2. So M should mean molarity. Molarity dot M, which is mole over what is it? Liter. Alright? And V, wait. Oh, I think it's better if I just wrote the dm cubed. Mole over dm cubed. Alright. And V should be in the form of, let me think, either liter or dm cubed. Okay, today we learned that the reason they use dm cubed is because it directly translates into liter. For some reason they based it off decimeters of all things. Could have been meters, but no, they chose decimeters. Oh, let me drink water again. Again, stay hydrated. My ulcer's killing me right now. So let's have let me think. So this is a concentration, right? So mole per, so let's say I made a square. Why did I move this away? I should move this away. Let me sit closer as well. No, I'm right-handed. I can't write like this. Let's see. Let's say the molarity of the hydrochloric acid is about 2 mole. Wait, what? 2 mole per liter. 2 mole. No femboy. I'm sorry. You're the person who said something about femboys in the group. Okay. Okay. This is the form that we're used to. dm cubed. Apparently, dm negative cube, inverse of cube. So this will change. Okay, this will change depending on the volume, because in a given solution, right, there's only a certain number of, this means like a certain number of atoms in a certain given space. So per dm, it means that in 1 liter there's 2 moles of acid, for example. So in this case, since if you're adding water into a concentrated solution, a stock solution for this case, you'll have less. Oh no, it's more spread out. So using this logic, let's imagine a little square with two circles. And if we were to increase the volume, the number of atoms or molecules remains the same, just that the volume is different. So there's nothing to think more about. It's just I think I'll sleep on this. Well, assuming it's 2 moles per dm, let's say let's say 1 liter for this. 1 liter, this is 1 liter, this is 3 liter, which is the same as 1 dm PADU, 1 dm cube. This is also the same as 3 dm cube. I'm so shocked at the fact that 1 liter is based on 1 decimeter cube, which is very surprising. So in this case, it will be 2 more dm cube times 1 dm cube equals this M1, this V1, and M2 should be, I want to figure out the molarity of the concentration once we fill it up with a bit of water, maybe around 3 decimeters of water, decimeters cube of water. Hello Noji, welcome. dm cube, okay. So I have to do some crazy formula. So pop 3 over 2, no 2 over 3 mole per dm cube for the second one. Alright, this works out pretty well. Now let me lock in to open up. Okay, so this makes sense now. Okay, dilution, it makes sense. Now let's try an example. How many millimeters of a 5 molarity stock solution of NaCl are needed to prepare 100 millimeters of 0.4 molar? Okay, so this is really simple. Don't worry, I'm blind. I'm not looking at the answer yet. How many millimeters? Okay, so this is our first value. This is the stock solution. So M, 5M. Now prepare 100 millimeters of. Okay, so 100 millimeters. So the second. Okay, the second molarity of the required solution is 0.4 molarity, and the volume for the second one is 0.1 liter. So it should be pretty simple. It's just simple algebra. So 5m, I don't want m to be a unit, it's kind of weird to me. Volume 0.4, 0.1. Alright, so let's plug it in a calculator. Where in the world is my calculator? There in the world is my calculator. Wow, Zyme, you are really obsessed with femboys. You are really obsessed with them. So V1 should be 0.4 times 0.1 over 5, which should be around however 1 over 125. 1 over 125 liter, which should be around 0.8 millimeters. Wait, let me just pop. Yeah, 0. Oh god, that's how many? Wait, how many milliliters is in a liter? It's 1,000, right? So it should be 8 ml. Oh, quite useful. And it makes sense. It makes sense. It makes sense. It's perfectly logical. So how many grams? Oh, this is grams. Grams of NaOH required to prepare a 400 millimeters of a 3. Okay, how many grams? I think this one we need to use. Yeah, what can gram? Okay, we have this, right? How many grams? So NaOH, I need to know the relative molecular formula for NaOH first of all. So how many grams? Okay, let me write the formula first. M1 V1 M2 V2 to prepare a. Okay, so this should be 0.4 times 3. Okay, first of all, we've already have our initial formula. Now grams. It wants grams. Open up donations. Unfortunately, I don't know how to open up donations. And I don't think I want to open up donations. Since From the kindness of my soul, right? From the kindness of my soul. I don't want to take any of your poor people money. Wow, that made me sound really pretentious. I really need to refill my water bottle. So how many grams of NaOH? So if I were to multiply these two together, right, we'll get molar mass. Molar mass. So, but the thing is, so what's our goal? I forgot what's our goal. Our goal is to get moles per decimeter. Then how do we do this? Test. How do we do this? Okay, let me look back on the previous solutions. I just realized I did not solve any of these previous questions, which would probably be required for me to figure this out. Molarity, volume of solutions, blah 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 blah. How many moles? Moles. Oh, I need to figure out the amount of moles first. The thing is, it didn't give us any. What the hell? Like 666. No. Solution. How many grams? Mole. I don't think we can use the formula here. So I think we have to do something about grams per mole equals to. Okay, I'll just write this down first. Mole. Oh, I have an idea. So you guys remember in physics, right? Of all the places I got my ideas from physics. So basically there's a conversion factor. Right now we need gram, only gram. Wait, did I not just do this? Wait, I think I remember. M times L times. What's the last one? M times L times grams per mole. So how do I get grams per mole? Molar. Okay. So first off, I need the liter. So it should be 0.4 liter times the molarity, which is 3.0 molarity, times grams per mole. So what's Gemini, my lovely Gemini. What's the RAM of NaOH? Okay. Oh, molar mass 40 grams per mole. I knew that to begin with. 40 grams per mole. So in the end, it'll all cancel out, and lovely calculator will calculate everything for us. 0.4 times 3.0 times 40. So we get 48. We need 48 grams. Henceforth, we need 48. Yeah, that's right. That's the right answer. Hello, Colin. I'm complaining about my ulcer right now because it fucking hurts. So for the next thing, given a 6 molarity H2SO4 solution, how would you prepare a 250 ml of 0.6? Isn't that simple? That's relatively simple. It's just using our classic formula. M1V1 equals M2V2, which is 6 times, what's our volume? Oh, we don't have volume yet. V1 equals 0.6 times 0.25. And of course, there's always something called shift solve. So 6x equals 0.6, 0.25. 0.2, we need around 25 ml. 25 ml. Now my question is, where the hell do you even obtain a 6 molar? OBS Studio. Okay, that scared the hell out of me. Oh my god. Oh. What the hell? Oh, okay. You do not scare me like that, OBS. Alright, so the next unit of concentration. Concentration. This is a game of concentration. Lila, something there. Wow, this is sad. I have no water. Aw, I need to refill these. I really need to refill. Later I'll refill once it reaches the 50th minute, which is probably not very sustainable. Cheers. So we need to practice more molality now. So molality, let's see. Molality is pretty simple. It's just the molarity based on the weight. Instead of based on the volume, it's based on weight now. Henceforth, what's the molarity? Okay, let's try to solve this without using anything special, like any special formula, or using the example. I'm currently turning a blind eye to this right now. Fast forward. Okay, what's the molality when 35 grams of NaCl is dissolved? So this is density of H2O. 1 gram over ml. This is quite molality. So basically we need to figure out how many grams. Oh, okay, got it. I got it. So basically we need to first convert the the volume. So 2.5. Okay, I need to do conversion factors. So 0, okay, 1 over 1 gram over 1 ml. That's roughly the density of H2O. So I need to do some fancy conversion factor. 1000 ml per 1 liter times. Wait, no, I don't think I need to times anything else. Wait, no, I need to convert it to. Never mind, it's all grams. So in this case, 1000 grams per liter. It does make sense now that I think about it. I didn't have to do anything fancy. So in this case, 2.5 liters of water. So I have to. It's the ratio between the solute and the. Oh, I don't know. Find the number of moles of solute. I just gave up. Number of moles in the solute. First of all, I did not know NaCl was that big. NaCl equals 58.5 grams per mole. Okay, I did not know that. And 35 grams of NaCl is dissolved in 2.5 liters of water. So in this case, we need to find. Oh, that makes sense. That makes sense. How could I have been so stupid? I should have founded the mole first. 58.5 grams per mole. This gram. So cancel. 35 divided by 58.5 is 0. It's about 0.598 mole. No molality, but just mole. So calculate the mass of solvent. Okay, yeah, I already have the conversion factor up here. So 1000 grams per liter times 2.5 equals 2. 1 2 3 4 5 1 2 1 2 3 2500 grams. Okay. Is that right? Liter. Okay, yeah. So that's about 2.5 kg. So in this case, once we got this, we could just mole over 2.5 kg. What's the point of knowing molality? 0.598 over 2.5 kg. And it should be 0.2392 mole per kg. Didn't even need help. First try. Okay, what's the molality of 0.5? Okay, let's try this not using anything. First of all, what's NaOH molarity? Not molarity, RAM, relative atomic mass. Should be about, I swear I wrote this somewhere. I don't remember. Oh, 40. NaOH is exactly 40. So NaOH equals 40, which is equals to grams per mole. So we got the molar mass, and now 0.2. Okay. In 500 grams of water. So I'm going to cover this real quick because I do not want to see the answer. Per mole, 500 grams of water. So 500 grams of water, we already know the kg. Okay, let's find the weight first. Since molality, what's molality? Oh, it's just lowercase m. Since molality is mole per kg, we need to find the kg part first. So kg part should be simple. 500 grams equals 0.5 kg. Okay, that's relatively simple. 0.75. Okay, just divide them by normal. Why did I have to? I did not have to do it. Wait, per kg. Do I have to add them together? No, I don't. I can just do this regularly. 0.75 over 0.5 equals. Lovely calculator. What the hell? What happened to my... Give me a moment. What happened to the phone? Oh my god. Oh my god, it turned off. Wait, is it connected to the UM's internet now? Oh my god, this is actually connected to UM's internet. Oh, thank you, UM. The thing is, my phone ran out of battery. So, the solution is simple. Just let me turn this off real quick. I'm sorry, my roommate Retza. Now next I can't disconnect this one. What is this connected to? Where is this? Where is this connected to? Oh my god. Sorry, technical problem. I'm putting the power stuff on the table. Okay, so let me turn. Okay, hold on. One. Okay, hold on. Technical problem. So how's your day? You guys got any girlfriends now? Just making small talk. If any one of you got any girlfriend, just tell me. I probably don't know you. But congrats. It's only been like 2 weeks in PASUM, right? And I just feel like I was looking at some, PASUM confessions. Everyone knows PASUM confession. So if you're in PASUM confession, you'll see how people are talking about their girlfriends or like wanting to get girlfriends, this and that. And me and my roommates were like, "Huh, what the hell? That's so early." It's only like the second week of PASUM. Why are you not? Oh wait, just give it a bit of a moment. Let's use PASUM. I'll just use PASUM for once. Am I using the guest or student? I'm using student. Concentration, concentration. This is a game of concentration. Okay, should be working decently now. If I were to refresh this, it should work. It should work. Refresh. Refresh. Oh no, that's refreshing the timer. Wrong refresh. Refresh this. What the balls? Okay, let me see the. Oh my god. Oh my goodness. I need to change everything. Hold on. Okay, let me just copy this. I'll beam it over to my laptop. Beam. And then I should be able to roll right about I should be able to roll right about now. Oh my god, I went to studio mode. Oh yeah, okay, fix it. Oops. It's small, it's tiny. Give it a moment. Is this the wrong app? No, this is the right app. What the ball? I have standards. Do you think I would allow? Oh yeah, I think I have to do this instead. I have to do that. And then yeah, I had to do this. So then the size part, which one did I pick just now? Did I pick this? No, I think I picked full HD. Full HD. I think maybe. Oh yeah, I think I did. Okay, it's fixed now. So now I have to keep doing this. Unfortunately, with the timer, what happened to the thing? Oh, never mind. So mass of solute should be 1.5 kg moles per kg. Okay, whatever, I'll just accept that that's the case. Oh, now what's next? Calculate the molar concentration of 100 grams of sucrose is dissolved in 1.5. Wait, it already gave us the answer directly. So 0.1 kg and molar. So it wants in kg. Okay, we have kg now. Now we need mole. GM per dm. Grams per. Wait. What's sucrose RAM? Do I really need RAM? So molar concentration we need in form of mole per kg. We need in that form. We already have the kg. We have kg part. We don't have the mole part. This is why practice is very important. You don't know what you don't actually know like what you're not gonna get. So mole per kg. Well, let me think. Mole per kg. How do you get mole per kg from here? 100 grams of sucrose. 1.5 liters of water. It's perfect to find the molar, but it's not. You can't find the molar yet. So if I were to get the molar mass, or to divide, I'll get molar. Okay, got it. But did I get it? 100 grams of sucrose. 100 grams of sucrose. Okay, it's way too late. What's the... Okay, man. The moment I don't want to use this. Okay, pop up virtual keyboard. Oh my god, come back. What's the answer for slide 9? Let's see. Slide 9. Let's. The answer for slide 9 is. Oh, wait, molarity. So the answer for slide 9 was. You have to use this formula. Sorry, you can't see the formula right now, but let me write a bit bigger. Gram. Wait, what is it asking for? Molarity of 5 grams of NaCl. Did I do this? Wait, I sure I did this, but for some reason I don't remember. Oh, surprisingly I did not actually do it. So the molarity of 5 grams of NaCl. Oh wait, no, I did do it. It's on this one. So the molarity is 58 grams per mole. Wait, molarity. Am I stupid? Okay, no, I'm actually done. Okay. They see me rolling. Thanks for bringing that into my attention. I actually did not solve this. So the molar mass is... Hold on. The molar mass is 58.5 kg. We have kg. Grams. And then we need to find the mole. So 58... 5 grams divided by 58. 58.5 grams per mole. And let's see, what's the answer? 58.5. So the amount of mole in this thing, it should be 0.085 mole. Alright. And after we get the mole, we should, since it's asking for molarity, it's mole over volume. So in this case, the answer should be 0.085 over 0.250 liter, which is 0.085 divided, which is 0.34. Should be 0.34 M, big M. Yeah, that's the answer. That's the answer. Do you see this? The answer is 0.34 M. Now, I regret to inform you that I need to go borrow the toilet real quick. Have fun while I'm gone. I'm gonna go piss. Yahoo, I'm back. Except I only came back to put my water bottle back. I'm gonna go actually pee now. Yahoo, I'm back. Ah. Okay. So, preparing solution, 5 grams. The answer was 0.34 for your answer as they see me rolling. What else? A bit weird. Right. Yeah, these questions are pretty difficult for me. Welcome to RSG banking app. Wow, thank you. Units of concentration. Concentration. This is a game of concentration. Don't get it, honestly. Units of concentration. Well, let's see. If it's units of concentration, did I solve this? Did I solve this? No, I don't think I solved this. 0.34. Oh no, I definitely did not solve this. Wait, I did. No, never mind. I did solve this. I did solve this. Wait, what? Did I? No, I did not solve this. Alright, so calculate the molar. Bless me, sorry. Calculate the molar concentration with 100 grams of water of sucrose. So that sucrose is 0.1 kg dissolved in 1.5 liters of water. This is the information that we're given. So what's the molar mass? Sucrose. What's the relative atomic mass for sucrose?
The relative atomic
Okay,
mass
great. It's around. Sucrose is
342.30 grams per mole.
342.30 mole. Alright. Grams per mole. Grams per mole. So in this case, how will we get kg from liter? That's my question. This is why chemistry is my worst subject. I mean, it's not exactly convincing now though. Alright, molar concentration. How do I get molar concentration? From liter. Where do I get liter? Cause So the current sucrose should be 100 divided by 342.3, and that should be the current molarity of sucrose should be 0.292 mole. Alright, so how do we get kg, moles per kg? 100 grams of wait, hold on. M times L times gram per mole. I think we need to use this. To you guys who's watching the video right now, are you just using this as a study together? Study along thing? Is it laggy, by the way? I wonder if it's laggy. The current glucose should be 0.292 mole. Molarity of sucrose should be 0. Let me see the video mole. Alright. Oh, it is laggy. Okay, I'm sorry. Hold on. It's cause like I'm using the I'm using UM's internet right now. So that's probably why it's laggy. I'm not using my hotspot. Give me a moment. I need to hotspot this real quick. Switch. I don't think I should switch internet while I'm in the middle of streaming. Stations, LAN 0, scan, connect, Bertha beam. Give it a moment. Changing my 100 grams of. Wait. It's a bit laggy because I'm not using my internet right now. So this should probably fix the lag. Maybe, I hope. 5G hotspot. Mic aux, properties. And I need volume because I don't think it's that loud enough. You guys can tell me what you think, but I personally don't think. Yeah, that's true as well. Okay, face scan me. You're cheap. Okay, cool. Let me in. Okay, it's changed. My port changed, so I need to update my port real quick. 19. Okay, I'm not going to say my IP out loud. 2.168.134.142. I said that I'm not gonna say it out loud, but I said it out loud anyways, which is kind of crazy. Size full HD, and I think the lag should be more tolerable now. I mean, there's only so much you can do with UM's internet, right? Let's set the gain a bit higher. 30 maybe. Alright, so how is it sound now? Does it sound good? Does it sound bad? The audio. Let's see. Let's have a listen. I mean, there's only so much you can do with UM's internet, right? Well, it's not. Okay, it's not up to date yet. 30 maybe. Alright, so how is it sound now? Does it sound good? Does it sound bad? Audio? I mean, it sounds decent. It sounds decent. I'm not too sure if you guys are bothered by, you know, the fan sound. So tell me if it's bothering you guys, or I have to turn on noise suppression, which I have to deal with a lot of stuff to deal with that. So if it isn't too bothersome, then let's continue doing it like this. I'm surprised at how much of you guys are actually watching. So grams per mole. We have 100 grams, and then we want the molar. Wait, this is the wrong formula. This is not the formula I need. Wait, or is it the formula that I need? No, it's not. Wait, is it? No, it's not. Mole. In a kg of solvent. Calculate the molar concentration when 100 grams of dissolved per kg. Liter. Liter moles. Do I need to use STP? 22.4. STP is 22.4 dm cube per. Wait, what the hell is STP? What's the unit of STP in chemistry? Oh.
STP is not a unit, but a set of conditions. 0 to the power of circ.
Then what's STP 22.4 dm?
At standard temperature.
Oh, okay, that makes sense. That makes sense. Per mole, per mole. Why don't they just tell us to use liters then? Per mole, okay. dm cube per mole. Per mole. So that's STP. So in this case, it will also mean 22.4 liters per mole. Then what does that mean? We can find molarity from liters of water. 1.5 divided by 22.4 equals. Where's my calculator? That's my calculator. 1.5 over 22.4, which is about 0.067 mole. So let me think. So with this we can get once we have this we can get 0.067 over 0.1, which is about 0.067 over 0.1, around 0.67 m. 0.67 m. And let's ask dear Gemini to see if this is right. What's the answer for this? What's the answer for this? Let's see. Okay, that is completely different from my answer, which is alright, let's see. First we found a molar mass of this, 0.92 mole. That's what I got as well initially before I changed my topic. Wait, hold on. Dude, but the thing is, we need molarity. So how does that work? How to solve this? How do you solve this? And first of all, I need to charge my tablet because it's running out of battery. Molel. Okay, I know this says marathon, right? But it's quite late. So after this, I might just take a rest. It's 1.9. Oh, it doesn't say it here, but you need to assume like 1 liter of water is about 1 kg. 1 liter is about 1 kg of water. Okay, so this is the assumption that you need to make. So it's not too hard, it's just that you need to make some assumptions. So in this case, the answer should be 1.5 kg is 0.292 over 1.5. So the answer is around 0.195 molality. So since we've gotten this done, now for the next part, units of concentration. The mass of solute over... How long have I been streaming this for? I've been streaming for this for about around an hour. So, oh my gosh. Alright. So next things next. We need to figure out the percentage of concentration. So mass of solute over mass of solution, mass of solute over volume. Oh, there's different types of concentration, right? Alright, for the 7 people who are watching here right now, are you guys studying alongside, or are you guys just watching? For us. Alright, so mass and volume units must match. Yes, that makes complete sense. 8 grams of sugar. What is the concentration? Weight over weight of solutions form. It's just 8 over 42, right? Plus 8. Oh, okay. Total. Need to remember it's total. What is the percent by mass in which 41 grams of NaCl is dissolved in 331 grams of water? That's a good question. By mass in which dissolved. Tomorrow I'll just skim through every single lecture in general chemistry. Weight over weight. So 41 grams. So weight over weight, right? By mass. It says by mass, so it should be weight over weight. So in this case, 41 over 331 times 41 times 100. So what would that be? 41 over 331 times 41 times 100 should be 0.3%. It should be 0.3%. That does not look right. But why did I multiply? Addition, bro. Addition, not multiplication. So that's why it was so confusing. 11.02%. So what games do you guys play? Indicates that 100 grams of solution. This. Oh yeah. This makes sense. Because remember, like the those 100 grams question back in SPM or like recently chemistry. If your teacher didn't Surikawa skip. So yeah, it means 100%. You just assume there's 100 grams of a solution. So something like that, yeah. 15 grams mass percent of the solution. So it should be 15 over 225 plus 15 times 100. So this should be 15 over 235 plus 15. So 0.6. We gotta multiply it by 100 to get 6, so it should be 6%. 6%. So what is the molar concentration? Assume the density is 1 gram over... Assuming the density of the solution is 1 gram over 1 ml, what's the molar? Okay, this thing is the weight of mass over mass. Okay, so this is mass, since this is mass over mass, right? Oh, wait. So, you see this percentage, right? Okay, special info for people who came in the live stream. Since it's 6% is mass over mass, right? And this is a percentage is a ratio over 100. So in reality, this means 6 over 100 times 100, right? This is 6%. This is 6% equals. So if you were to remove the percentage, we would have 6 over 100. And what does that mean? On the right side here, it says mass over mass. So this would mean that this is 6 grams over 6 grams. 6 grams over 100 grams. Which means that implicitly, anything that has 100% in it, if you were to specify what type of 100%, what is it relative to, you should be able to get the answer directly. So in this case, 1 gram over ml. So first of all, what's the unit for... Okay, actually, wait, do I need to do this? I'll just do it. Let's do a conversion factor. 1 gram over 1 ml times 1 ml. What's 1 ml? Okay, it's 0.001. What the hell am I on? No. 1 gram over 1 ml times 1000 ml per 1 liter times 1 gram, 1 kg over 1000 gram. Cancel. Wait, not cancel this, cancel. Wait, what the hell? So we get about... Oh, in the end I just cancelled everything. 1 kg per liter. So in this case, if you were to convert that, right, to... I should not have done that. I should have just done it normally for now. Per 100 grams. Let me make it more specific. There's no need to make it more specific. Oh my god. How much did you guys answer? I did not know. Wait. The YouTube was lagging just now, so I didn't see your guys' text. Is this the RIS in Ohio? No, there's no RIS in Ohio. It's V loud. Volume is pretty loud. Oh, I'm sorry. So I'm not too sure if it's still loud now. M0.195. Yeah, that's right. That's the answer. RIS or Aura. It's swag. Oh my god, Anthony. Hello, I'm Anthony. March. Hello, March. Yeah, yes. So gotta think. Scan my face. Thank you for scanning my face. 1 gram per ml. Okay, let's convert. Okay, cancel. It should be around 6 gram per 100 ml. This is the part where we need to do a conversion factor. So 6 gram. Can I simplify this any further, by the way? I know I can, it's just I don't know how. Okay, it's just pretty simple. 3 grams per 50 ml. Alright, so this is the place where we start. Conversion from sorry, I'm getting pretty tired. So in this case it should be 1000 ml over 1L times 1 kg per 1000 gram. So in this case, I can just cancel ml with ml and grams with grams to get something 3 kg per, okay, 3 times 1000, 3000 kg. 3, what the hell? No, what the hell? I'm trying to calculate the molar concentration. What am I looking for, kg? What the hell was I yapping about? I thought I was cooking. No, I was not cooking at all. Let me think. Grams per grams. 6 grams per 100 grams. Assuming what's the molar concentration, we need the mole of this, so assume the density mass percentage. We already have the mass percentage, so how do we utilize it? Mass percentage. Assuming the density of the solution is 1 gram, that's per ml. That's not a mole, that's just a regular concentration. Oh no, this density is not just a regular concentration. What's the molar concentration? Density is another way of saying concentration. So mass percentage of the solution. I am spending way too much time on this. First of all, drink more water. Density percentage, molar concentration. Yo, this is such an easy question, yet I'm getting this confused. I am out of practice. I wonder if you guys texted and it's just YouTube not doing anything. Participants. Ooh, what's this? Oh no, I accidentally went to another YouTube video. The internet is incredibly slow. Chemistry grinding marathon. Alright. So let me try to figure this out. A solution contains let me skip this real quick. Let me go to another question. Glucose, this indicates that. How do I convert this to molar concentration? Assume the density of the solution is 1 gram per ml. What is the molar concentration? That is a very good question that I don't know of. I need to solve this eventually, but I'll skip it eventually. So what's the weight per volume? Okay. So the weight per volume should be. Does it want in kg or grams? It doesn't matter. If it's milli, it must be milli. Oh, okay, got it. So basically, if it's milli, it must be milli. If it's kg, it must be kg. So 40.0 grams per 200 millimeters times 100%, and it should give us a little known value of 1/5, which is 0.2. So it should be 0.2%. I did not multiply it by 100. It should be 20%. That's all. That's all. Okay, that doesn't matter. This is Volume per volume, it's simple. We just have to do some sort of conversion factor. So 0.35 liter in 7.0 solution. So we have to it doesn't say anything about adding, so I'm just gonna assume that it's already part of the solution, which is equivalent to 0.35 over 7, 0.05 liters. This will indicate that there should be 50 milliliters in 1 liter of solution. Parts per million, parts per billion. Okay, now what the hell is this? Oh. So what's... Oh, okay. So this is for incredibly low values. Incredibly high drinking value. Mole fraction. Yeah, I'm gonna be done soon. How do you use mole fraction? Okay, let's just use an example. In making a glass of iced tea, 100 grams of sugar is added to 400 milliliters of water. It's a mole fraction of sugar. So what the hell is this for? I think this is the way the ppm and ppb is too small of a value that it doesn't matter in the end. So it would mean that after this I'm gonna go sleep. Z. So 100 grams of sugar, mole fraction. So in this case, mole fraction, we need to find the molarity of this. So what's the molar mass? I'm too lazy, so I'm just gonna borrow this here. So sugar is 342 grams per mole. Okay. So we need to 100 divided by 342, which is around 2092 mole. And we need water. What's water? Water should 12, 14. Okay. So 400 milliliters of water. I don't know. Volume times density. What's the density? 1 gram per ml. Okay, this is something that we need to remember. Okay, 1 gram per ml for water. Water density is 1 gram per ml. I think that's the exact value for IUPAC, UPAC or something. Google. Mole water volume. Okay, volume is 400 times the density, which is, then we'll find gram. So around 1 gram per ml. This is ml. And gram, this should be molar mass, which is 18. Yeah, it is 18. 18 grams per molar mass, which is indicative. Oh, welcome back. There's 7 people watching now. You guys watch right as we're about to... Actually, no. Not yet. 22.2222. So 22.22 repeating over and over again. Mole. So after this, since we've gotten this already, right, we need to add them. Okay, first we add A and 22.22 mole plus 0.292 mole, which is 0.292 over 2.2 plus 0.292, which is 0. Is this right? This looks wrong. Wait, mole fraction? Oh yeah, it is right. This For the sugar, I'm calculating this for the sugar initially. Yeah, I'll have to do it the other way for water. So sugar, and for water, it should be 0.987. Is it additive? Oh, it is additive, yeah. So if you add both of the mole fractions together between two different bases of the same thing, it's going to add up to 1. So the next one was the mass of CO2. Okay, let me drink some water and then more water. What's the mass of CO2 dissolved in K? So after mole mass, okay. So we need to find the mole for CO2. That's the goal. That's the goal, okay? Mole for CO2 and water. So water should be 250 times the density should be 1 gram per millimeter over 18, which should be the molar mass of water. So 250 over 18 should be 13.89 moles. No, I am mole. That's incredibly a high number amount. So if the mole fraction, what's the mass dissolved in 250 millimeter? Okay. So since it's a ratio, right? We'll CO. So we need to find CO. So let okay, X 13.89 plus X equals 0.35. Okay, since we are using CO2 as our average, I don't care, equals 0.35. I say this is a marathon, but this isn't really exactly a marathon. So it should be around, X should be around 7.479 mole. Should be. And from that we can get, what is the mass of CO2? What's the mass? Okay. What's carbon's? Yo, Gemini, my love. What's the relative atomic mass for carbon dioxide?
The relative molecular mass.
44. Thank you. 44. So CO2 is 44. So we need to grams per mole. So 7.479 times 44, which is, what's this? Alright, whatever. Around 32903 grams of CO2. Okay, we're almost done. This is the last one before we're ending this. So consider a solution containing 0.5 moles of KNO3 and 0.3 in 100 pounds. Okay. So each compound will include water. In this case, it shouldn't be too difficult. So again, 100 grams times 1 grams per milliliter over wait, 100 grams of water. Oh yeah, 18 grams. What the hell? Hold on. I'm getting confused here. Grams per mole. No. I'm not supposed to use this. 100 grams over. What's the water? 18 grams per mole. So in this case, I'll get 18. So it will be 5.556 mole. Right after getting 5.556 mole, we should be able to each compound. So for KNO3, it should be 0.5 5556 plus plus 0.5 plus 0.3. Okay, I'm just gonna rewrite this over and over again. 5.556 plus 0.5 plus 0.3. For KNO3 it should be 0.079. Okay, now for moles of NaCl it should be 0.3. In this case it will be 0.047. And for H2O, roll of bros, should be 5.556. And then 0.874. So adding everything up does not seem like it totals up to 1. It does surprisingly total up to 1. Oh. And let's come back to this one question. Okay. Assuming the density of the solution is, what's the molar concentration? Molar concentration is per volume, right? So if it's per volume, it should be how do you get this? What the balls? Mass of solution 15 over 15 plus 235, which is 235 should be around 0.06, which is 6%. I'm just gonna shorthand everything. 0.6%. 6% should be molar concentration. 1 gram. Oh, is it just a way of saying that we don't have to worry about? Molar concentration should be mole per, in this case, liter. So if I were to assume, okay, there's 15 grams of, hell. Oh wait, what's the RAM of Na2 CO3? Alright, let's see. Oh, it's approximately, okay, we're almost done. I'd like to sleep soon. 5.99 grams per mole. Oh man, okay, we're almost done. Once we're done, we're going to sleep. Everyone's going to sleep. You don't have a choice, you're going to sleep as well. 15 over 105. Whatever, I didn't expect to spend this much of the time here. 142 mole. Now mole per liter. What's the entire liter? So the molarity should be 250. Is this milliliter? Wait, no, that's 1 gram per liter. Oh, yeah, we can assume that. Yeah, it's safe to assume. Then the molarity should be 0.142 over 250. Then here we get a very tiny amount, which is suspicious. The molar concentration is this low? Oh wait, no. 0.25 liters. Oh my. 0.25. Okay, this is more realistic. 0.568 big M. Okay, that's all. There's no more examples. I've referred to everything. And I'd say good night, everybody. Have fun on the weekends. Good night. Bye bye.